The floaters, giants in the clouds of Jupiter. The year is 1973. A spacecraft called Pioneer 10 hurtles through the void of space, approaching a destination that had existed only in dreams and mathematics: Jupiter, the king of planets, a world so massive that 1,000 Earths could fit inside its swirling storms. As the probe's cameras begin transmitting the first close-up images of this alien world, scientists at NASA's Mission Control lean forward in their seats, their hearts racing. The images reveal something extraordinary. Great bands of color twist across the planet's face. Storms larger than Earth itself churn through clouds of ammonia and methane. Lightning bolts 1,000 times more powerful than anything on our world crack across the alien sky. And in that moment, watching those first images flicker across the screens, two scientists begin to wonder the same impossible question. What if something is alive in those clouds? What if Jupiter, this hostile giant of gas and fury, harbors creatures unlike anything humanity has ever imagined? Not on a surface, not in an ocean, but floating, drifting, hunting through an atmosphere that stretches deeper than the distance from New York to Los Angeles? This is the story of the floaters, creatures that may never have existed, creatures that science can neither prove nor disprove, creatures that represent one of the most audacious and haunting speculations in the history of astrobiology. And even if they don't exist on Jupiter, the question they raise echoes across the cosmos. What forms might life take in the universe, and are we brave enough to imagine them? The man who dared to imagine life in the clouds was not some fringe theorist or science fiction writer. He was Carl Sagan, one of the most respected astronomers of his generation, a man who would go on to inspire millions through his television series Cosmos and his relentless advocacy for the search for extraterrestrial intelligence. But in 1976, 3 years after Pioneer 10's flyby, Sagan was haunted by a vision. He had spent years studying the atmospheres of other planets: Venus with its crushing pressures and sulfuric acid clouds, Mars with its thin, cold air and dust storms that could engulf the entire planet, and Jupiter, that enigmatic giant whose atmosphere was something else entirely. Sagan knew that Jupiter's upper atmosphere contained all the ingredients of a primordial soup: hydrogen, methane, ammonia, water vapor, the same chemicals that here on Earth 4 billion years ago had somehow sparked into life. Scientists had already proven this in laboratories. In 1952, researchers Stanley Miller and Harold Urey had taken those simple chemicals, added an electrical spark to simulate lightning, and watched as amino acids, the building blocks of life, formed spontaneously. The experiment had sent shockwaves through the scientific community. If life's ingredients could assemble themselves so readily in a test tube, what might happen in the vast chemical laboratory of Jupiter's atmosphere, where lightning strikes 10,000 times per second and organic molecules rain down like snow? But Sagan was a careful scientist. He knew the difference between possibility and fantasy. So he reached out to a colleague, Edwin Salpeter, a brilliant astrophysicist at Cornell University with expertise in stellar evolution and exotic physics. Together, they would attempt something extraordinary. They would design, on paper, an entire ecosystem, a food chain, a web of life that could theoretically exist in the Jovian atmosphere if the laws of physics and chemistry allowed it. They would publish their findings in the Astrophysical Journal, one of the most prestigious scientific publications in the world. The paper was titled "Particles, Environments, and Possible Ecologies in the Jovian Atmosphere." It would change the way humanity thought about where life could exist. To understand the floaters, you must first understand their world. Jupiter is not like Earth. It has no solid surface to stand on, no ground beneath your feet. If you could somehow descend into Jupiter's atmosphere in a spacecraft, you would fall for hours, watching the sky around you shift from the pale yellows and whites of the upper clouds through deeper oranges and browns, the pressure building, the temperature rising. At first, the atmosphere would be thinner than Earth's, cold enough to freeze nitrogen, but as you descended, the air would thicken. The pressure would climb to match sea level on Earth, then exceed it. 1 atmosphere of pressure, 2, 10, 100, and you would keep falling, down through layers where the temperature climbs past the boiling point of water, where the pressure would crush any terrestrial creature into a smear of organic molecules. Eventually, thousands of miles down, the hydrogen gas that makes up most of Jupiter's atmosphere would be squeezed so tightly that it would transform into a strange metallic liquid, a sea of hydrogen atoms pressed together until they conduct electricity like copper wire. And deeper still, at the very core of the planet, temperatures would soar to 30,000 degrees Fahrenheit, hotter than the surface of the sun. This is the realm where Sagan and Salpeter imagined life, not at the hellish depths, but in a narrow band of atmosphere where conditions were, if not friendly, at least conceivably survivable. A layer perhaps 100 miles thick, where the temperature hovered around room temperature, where the pressure matched Earth's atmosphere, where sunlight could still penetrate and ultraviolet radiation could drive chemical reactions. This habitable zone existed, the scientists calculated, at the same altitude where we see Jupiter's colorful cloud bands from Earth. But there was a problem, a terrible, insurmountable problem. Jupiter's atmosphere is not static. It churns, it boils. Massive convection currents drag air from the cold upper atmosphere down into the hot, crushing depths, then cycle it back up again, like a massive conveyor belt of doom, constantly circulating. Any small organism drifting in Jupiter's atmosphere would eventually be carried down into the deep, where the heat and pressure would tear it apart, breaking its complex molecules back into simple gases. It was, Sagan and Salpeter realized, a death sentence on a planetary scale. Any life that formed in Jupiter's habitable zone would inevitably be dragged down into the inferno below. Unless the organism was large enough to resist those currents, unless it could actively fight against the downward pull, unless it could somehow float. And so the floaters were born, not from observation, not from any telescope or space probe, but from pure theoretical reasoning, from following the harsh logic of physics and biology to its inevitable conclusion. If life existed in Jupiter's atmosphere, Sagan and Salpeter argued, it would have to be vast beyond comprehension, kilometers across, beings the size of cities, drifting through the clouds like living balloons, each one a self-contained ecosystem larger than the greatest whale that ever swam Earth's oceans. The scientists envisioned them as enormous bags of gas, membranes kilometers in diameter, filled with heated hydrogen, the lightest element in the universe. By pumping helium out of their bodies and retaining pure hydrogen inside, these creatures could generate lift just like a hot air balloon floating over Earth's countryside. They would drift on Jupiter's fierce winds, traveling around the planet in great herds, their translucent bodies catching and filtering sunlight for energy, photosynthesizing in the pale light that penetrated the cloud decks. They would be, in essence, living sky cities, each one containing more biomass than an entire terrestrial ecosystem. The artist Adolf Schaller, who would later work on Sagan's Cosmos television series, brought these creatures to life in a painting that would become iconic. In his rendering, the floaters appear as vast, jelly-like beings, their bodies glowing with bioluminescence, trailing gossamer tendrils through the russet and amber clouds. They look serene, almost peaceful, these giants of an alien sky. But Schaller's painting also hints at something else, a sense of scale that defies human comprehension. A single floater dwarfs a terrestrial mountain range. These are not mere creatures, they are living geography. But how would such beings evolve? Sagan and Salpeter tackled this question with the same rigor they applied to stellar physics. They proposed that Jupiter's ecosystem would mirror, in some ways, the ecology of Earth's oceans. Just as life in the sea began with tiny plankton, Jupiter would need small organisms at the base of its food pyramid. They called these organisms sinkers, microscopic or small multicellular creatures similar to bacteria or protists that would reproduce rapidly in the upper atmosphere where organic molecules formed from lightning-driven chemistry. These sinkers could not fight against Jupiter's convection currents. They would slowly fall, drifting downward like marine snow in Earth's oceans, providing a constant rain of organic matter to feed larger creatures. The floaters would feed on these sinkers, filtering them from the atmosphere like baleen whales filter krill from the sea. But an ecosystem cannot exist on herbivores alone. Sagan and Salpeter knew this. Nature abhors a vacuum, and it abhors easy prey even more. And so they imagined a third type of organism, the hunters, fast, maneuverable predators that would pursue the floaters through the Jovian sky, attacking them for their organic molecules.